Hello, welcome once again to Mathspirational. In the last video in this series, we looked at finding the gradient of y equals x squared at a particular coordinate at one point when x is 1.2. What we'll look at today in this video is finding an equation or a function that will give me the gradient of y equals x squared at any point along that curve for any x coordinate. So all I have to do is substitute in the x coordinate and bingo, it gives me the gradient at that point. Okay, so the way we go about doing this is we pick our point A and we say it has an x coordinate of x and it's going to have a y coordinate of y. And then pick another point B and say that it's got an x coordinate of x plus delta x, which as you'll recall means x plus a little bit. And that means it's going to have a y coordinate of y plus delta y. Okay. Now, again, as you'll recall, what we're going to do is we're going to estimate, or actually calculate, in this case, the gradient of that tangent, the green line, by finding the gradient of that chord. And then what we're going to do is we're going to say that delta x, the difference between our 2 points, becomes infinitely small. Because once that becomes infinitely small, the gradient of the chord will be the same as the gradient of the tangent. So let's have a look then. So we've got y equals x squared. So it means at A, we're going to have coordinates of x. And we know y equals x squared, so that's going to be, the y coordinate is going to be x squared. At B, we're going to have coordinates of x plus delta x. And the y coordinate, well, I've labelled on the graph is y plus delta y. But we know that the y coordinate is equal to whatever the x coordinate is squared. The x coordinate is x plus delta x. So the y coordinate is going to be x plus delta x squared. Okay. So then, the gradient of that chord, that blue chord, that's going to be delta y over delta x. So delta y is the difference in the y coordinates between A and B. So that's going to be x plus delta x squared, take away x squared, the difference between the two y coordinates. For x plus delta x squared is the y coordinate of x, of A, and x squared, wrong, completely wrong, where x plus delta x squared is the y coordinate of B, and x squared is the y coordinate of A. And then in our denominator, we're going to have delta x, which is, well, it's going to be x plus delta x, the x coordinate of B, take away x, the x coordinate of A, and straight away we see that they cancel out. Okay, so in our next line, we're going to expand that numerator. So x plus delta x all squared is going to give us x squared plus 2x delta x plus delta x squared, take away x squared, all over delta x. And once again, we see that things cancel out. The x squared and the minus x squared cancel out. So that leaves us with 2x delta x plus delta x squared all over delta x. Now hopefully you'll have spotted that we can take a factor out of that numerator, we can factorize it to give us delta x lots of 2x plus delta x over delta x. And we can see that our delta x is cancelled. Delta x divided by delta x would be 1. That gives us 2x plus delta x. So delta y over delta x, the gradient of that blue chord, is 2x plus delta x. Now, earlier I said what we're going to do is we're going to bring point B really, really close to A. We're going to have delta x become close to 0. We're going to imagine what happens as delta x gets close to 0, that means it becomes infinitely close. Now, as you recall from my first video in this series, if delta x becomes infinitely small, it ceases to be delta x and it becomes dx. So what we're going to have is dy over dx, our infinitely small change in y over an infinitely small change in x, is equal to the limit as delta x tends to 0 of 2x plus delta x. Which leaves us with the question, what happens to 2x plus delta x if delta x tends to 0? Well, let's have a think about it. 2x, well, has nothing to do with delta x, so that's going to remain the same. And delta x, which said it's tending towards 0, is becoming close to 0, so we ignore it, it becomes 0. So remarkably, we're left with dy over dx, which is the gradient of our chord once delta x becomes infinitely small, as 2x. And because a change in x is infinitely small, it means it's the same as the gradient of a tangent. So that's equal to the gradient at any point. Now you may recall, if you watched my last video, that the gradient of y equals x squared at x equals 1.2 is 2.4. We know now that our gradient for y equals x squared at any point is just 2 times the x coordinate, so 1.2, that'd be 2.4. Clearly that's right. So what we have there is a method for finding the gradient function of any equation, simply by saying x plus delta x, find the difference in our numerator, find the difference wrong in our denominator, find the difference between the y coordinate in our numerator, and then say what happens when delta x tends towards 0. In my next video, we'll be looking at doing that with a different polynomial. The next video after that, we'll do it with a different polynomial, and from there we'll see if we can generalize. Thank you very much for listening. If it helps, please like and subscribe. Thank you.